Hi, so in this video we're going to look at the geometric data search from within Safari. So again, I'm going to start at the sponsor dashboard and I'm going to click either on geometric data down here or just on data up here. And when I click on that, I get the standard Safari search tools, which are a bunch of filters. And effectively, I can filter down from gross depositional environment, sub-environment, all the way down to architectural elements. And in this case here, the numbers behind the titles or the filters refer to, first of all, the number of studies, and then secondly, the number of geometric measurements that sit within that study. Now, generally, the logical way to filter down is to start on the gross depositional environment, to decide I'm interested in alluvial deposits, and then I go into the sub-environment, perhaps fluvial deposits, and then to select certain architectural elements. Now, at any stage, I can select any or more than one, or just a single one of these elements. Perhaps I'm going to select all of the different types of channel belt in here, and then I can select my data source up in here. I'm just going to leave all that as set. I can filter by basin type. Again, for this, I'm just going to leave that as unset, which means it'll use all of the data. But I do actually think I want to filter by climate, so I'm gonna select a warm temperate climate, which is telling me here that there are 1,500 measurements in here. So once I've set that up, I can then go over to here. Then this is the graphing tool. Now I have a choice between what we call absolute and average measurements here. Now, absolute measurements are where somebody has specifically gone out and measured a particular geometric element in the field, and that element is unique. So there are, in this case, 3,291 measurements in here. Where it says average measurements, this is what you use when we have gone out and we've gone through the literature, and in a particular article it says that there are perhaps, in this particular cliff section, the channels have a particular width, an average width of 150 meters. Now, average readings are obviously not as good. There are less data points in them, but sometimes that's all the data that you'll have. So generally, providing there are data in the absolute measurements, I would generally just click on that. I can also, measurements are classified on measurement quality and completeness, so I could filter out on that. I'm just going to pull up everything for the time being. Now I'm going to select whether I want a cross plot or a bar graph. So I will select the cross plot here, and I'm going to plot channel belt width against channel belt thickness. And once I've done that, I'm basically just click on view the graph. The graph will appear in a new window. Now, what you see down here is a list of all of the studies that are included in this plot. So I can look at this and I can get the statistics for this particular population of data. I can get my P10, my P50, and my P90. I can also see the particular data points. If I hold down the left mouse button and click, I can also zoom in to look in more detail at a particular part of the graph. I can just reset the zoom like this. And perhaps I think that actually this point out here seems quite anomalous. This doesn't really fit in with the rest of my data. So what I'm then going to do now is I'm going to go back and I'm going to go and select all of my studies and then deselect that study. Or I could just choose to only plot that study if I wanted. And I create a new graph now, and we see that is no longer included in the data set. I can export these data to a CSV if I want to. That means effectively it's a comma separated value file, and that can be imported directly into Excel if I wanted to do some more sophisticated analysis to the data. It'll just export a data table. So those are that's the data search tool. You can start. You can also start. You don't have to necessarily, if I reset all the filters, you don't necessarily have to start at the gross depositional environment level. I might just go and select some architectural elements. If I knew I specifically just wanted a particular type of channel, I can select just select directly from there. I can start at the depositional level. I can do it however, I can search however I want. It's pretty flexible. And if I only want data from the Escanilia in Olson, from the original Safari data, I can also just filter. Like so, and you'll see that there are 69 points. And again, I'm going to create a query of absolute measurements. I'm going to select width against thickness again, and I'm going to view my graph, and that's just giving me the data from that one particular location. Ideally, this is a tool that will enable you to get out geometric measurements to use in object-based modeling. We are currently working on tools that will enable you to extract variograms and MPS training images. At the moment, the main numerical input for reservoir modeling from Safari is through this tool, and ultimately it helps you to quantify and qualify what you're going to put into your reservoir model. And the key point here again is that it's auditable. If somebody says to you, why did you choose that particular value as the mean thickness for channels, you can go back into here and you can say, well, it's because I did a search on Safari on channel belt dimensions. I used the Escanilia as my analog, and that's why I chose those properties. So it's completely auditable and reusable for your data inputs to the object-based models. So there are currently about 5,000 or 6,000 measurements. We're in the process of uploading more. By the end of phase 3, I think that'll be up around 10 or 11,000. We hope you find it useful, and give us some feedback on how it goes.